Hi everyone, let's go over chapter 3.3 Solving Right Triangles Part 1. Example 1. Calculate each trigonometric ratio. So recall back from last class we talked about how to remember sine, cos, and tangent ratio. We denote it as SOHCAHTOA. And we'll use this ratio to solve state the ratio. First, we were given angle theta. We were given 3 lengths of the sides. So first, the side that's across from the angle theta, this side would be the opposite side. The longest side of the right triangle is hypotenuse, and the missing side would be the adjacent side. Knowing that SOHCAHTOA exists and we know sine theta is going to be opposite over hypotenuse, we can just substitute in the opposite, so 4, and hypotenuse is 5. For cos theta, we know it's adjacent over hypotenuse. So adjacent is 3, hypotenuse is 5. Tangent theta equals opposite over adjacent. So opposite side value is 4, and adjacent side the value is 3. Moving on to example 2. Calculate the angle theta in each triangle. This time we're not looking for the ratio, we're looking for the angle. Let's take a look at what we're given here. We have angle theta, that's what we're looking for. We have, actually this is opposite side, and this is adjacent side, and hypotenuse, and we were only given the hypotenuse and adjacent side. So we need to first decide on which trig ratio we can use, and that ratio cannot involve opposite side. So we're going to do SOHCAHTOA here. Oops. SOHCAHTOA. And a ratio that does not involve opposite would be cosine. So cos of theta would equal to adjacent over hypotenuse. And this one involves theta, adjacent side, and hypotenuse. So we can do inverse cos or arc cos. So if I were to find theta, I need to arc cos it. Hold up, so this is going to be so cos of theta here and A over H. Let's take a look. So the left hand side becomes theta and the right hand side becomes cos inverse of adjacent 36 over hypotenuse is 47. Alright, so our cos 36 divided by 47 equals 40.01. That equals 40 degrees. And again, double check if your calculator is in degree mode. So we'll follow the same step for part B. Our angle theta is given in the corner there, so this time we're given the opposite side and adjacent side. We don't have value of hypotenuse. When we're choosing trig ratio, we have to make sure that that ratio does not involve hypotenuse. So in this question, we should use tangent ratio, opposite over adjacent. So same step, theta equals arc tan of opposite over adjacent. So sub in the values we have for opposite, 87, adjacent is 26. So arc 10, 87 divided by 26 equals 73.3. So that's it for example 2. Now we are on example 3. Calculate the missing side of the triangle using 2 methods. First method would be Pythagorean theorem, and the second method would be trigonometric ratio. Alright, so Pythagorean theorem, we all know that this formula is valid for all right triangles where C is the length of hypotenuse, the longest side. So if we label it, it'll be A and B is interchangeable, so I can just set the question mark side as A, B, and C, and we can actually solve for the missing value, question mark, by setting up our theorem. So A would be, let's say, X. Okay, so X squared plus B is 48 squared equals C is 73 squared. Using our calculator, we'll take away 48 squared on both sides. And I don't expect you to do this in your head, so please use your calculator and it's okay. So we have x squared equals 3025. Next step would be square rooting, and we learned this in the radical unit. So we have x equals 55. So our missing side, question mark, this side equals to 55. We solved it by using Pythagorean theorem. This time we'll use trig ratio. This is method number 2. Let's set up our side, names of the side first. So we have angle theta, and the opposite side would be called opposite, adjacent, and then hypotenuse. And so we could use one of the trig ratio, so Katoa. So let's see, this time we just need to make sure we have opposite because we're solving for opposite. And with the angle theta, we need either adjacent or hypotenuse. So let's say we can use either sine theta equals opposite of hypotenuse, or we can use tangent theta equals opposite over adjacent. You just gotta make sure that there's only one missing value, and this case would be the opposite side. So let's actually solve this in 2 ways. So sine theta first. So we have sine of 48.89 equals, we don't know the opposite, we'll just call it x, and hypotenuse is 73. If I were to multiply 73 to both sides, we get 73 sine of 48.89 equals x. Let's check the calculator. We have 73 times sine of 48.89 equals 55.002. So we'll call it 55. So x equals 55. So we can confirm that yes, it works, and we verified it using sine ratio. Let's use tangent ratio. So tan of 48.89 equals opposite over adjacent, which is 48 degrees, 48. We multiply both sides by 48. You get 48 tan of 48.89 equals to x. And again, punch into our calculator. 48 times 10 of 48.89 equals 55.004. So we can actually round it up to 55. We have confirmed that the missing side is indeed 55. To example 4, solve the given triangle. Find all the missing values. So it looks like we need to solve for y, angle M, and x. Let's label the names of the side depending on which angle we're referring to. So let's say if this is an angle theta, y relative to angle 41 degrees would be the opposite side. And this would be adjacent side, and hypotenuse would be 70.3 centimeter. Right, so first thing I would like to do is recall back to the sum of interior angles in a triangle. Okay, so the sum of angles in a triangle equals 180 degrees. And we're going to use this in order for us to solve for m first. So let's say there's 180 degrees, and the sum is that 41 degrees, this angle here, and that right angle here is 90 degrees, and the missing angle is m. So we know that this must be valid. Right, so let's collect the like terms here. 180 degrees equals 131 degrees plus m. So when you take away 131 on both sides, you get m equals to 49 degrees. So we have found the angle for m. Now let's take a look at y. Solve for y. And note that y is the opposite side relative to the angle 41 degrees. Okay, so we need to use a trig ratio that involves opposite but not adjacent. We can't use adjacent because we don't know the value of adjacent. So the correct trig ratio we can use would be sine theta. So we can say that we have the opposite, y, we have the angle theta, which is 41, we have that value, it's not unknown, and we also have a hypotenuse, which is also known. Okay, so we can just sub in all the values we know. Sine of 41 degrees equals opposite is the one we're looking for, y, over hypotenuse is 70.3. Alright, so we'll just isolate y by multiplying 70.3 to both sides. So we have 70.3 times sine of 41 degrees equals y. .3 times sine of 41 equals 46.12. 46.12. We were, and centimeter, oops, centimeter, don't forget the unit. If it's given to you, you have to use a unit. So we solve for y, and now our missing missing value would be x. So let's solve for x. Also, if you use m as your main angle, then your x would be the opposite side. But I strongly suggest you not do it this way, because in case you make a mistake solving for m, you don't want to use the wrong value to solve for the other. You want to make sure to stick to the values they give you unless there's no other way to solve it, right? Okay, so let's solve for x. We're going to use a trig ratio that involves adjacent but not opposite, which is exact opposite of when we're solving for y. Okay, so in this case, our trig ratio would be cos theta, which is adjacent over hypotenuse, because we can't use opposite. So let's sub it in. Cos of 41 degrees equals adjacent is x. Hypotenuse is 70.3. You multiply both sides by 70.3. You get 70.3 cos of 41 equals x. 70.3 times cos of 41. So this equals to 53.06. X equals 53.06 centimeter. So this is it for today. I'll see you guys in the next video.